Today, we'll look at this question from 2013 Grade Junior Math Olympiad. We are asked to write this expression as a sum of square of two consecutive positive integers, meaning that we want to write k as some p square plus p plus 1 square. The key idea for this is to express each of these terms, m to the power 4 plus 1 over 4, as some expression. Then later on, perhaps we can use the idea of telescoping products. Have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
As suggested, we note that for each of these terms, it is of form m power 4 plus 1 over 4. And we can write this as m to the power 4 plus m squared plus 1 over 4 minus m squared. Now we combine the first three terms, and this will give me m squared plus half, the whole thing squared, minus m squared. Then this is the difference of two squares, so it will be the first plus the second one, and the first minus the second one. After which we can see that this can be written as m plus half square plus 1 over 2 square. So when you expand this, we will have m squared plus m plus 1 over 4 plus 1 over 4, that's 1 over 2. And for the other one will be m minus half square plus 1 over 2 square. So each of these can be written as the product of sum of two squares. Okay, for now, I'll copy the result so that I have more space. If you enjoyed this video, please like, comment, and subscribe. So now we know that k can be written as, the general form will be 2a to the power 4 plus 1 over 4 over 2a minus 1 to the power 4 plus 1 over 4. And we take the product run from a equals 1 to n. And we know that for each of the terms, it can be written as this form. That is, for here, this is 2a plus half square plus half square times 2a minus half square plus half square, and over, so for this, it is 2a minus 1 plus half square plus half square times 2a minus 1 minus half square plus half square. Okay, now note that this is 2a minus 1 plus half. Actually, this is 2a minus half square. So this is also 2a minus half square plus half square plus half square. So this can be cancelled off. They are exactly the same. The second thing that we can note that is this is 2a plus half square plus 1 over 2 square. And for this, it can be written as 2a minus 1 plus half square plus half square. Okay, note that this is 2a minus 1.5. So it's 2a minus 2 plus 0.5. So they are exactly the same. Now, they have exactly the same form. So after you write it, most of the term can be cancelled off except the first one and the last one. So the first one will be when a equals to 0, that will be a half square plus a half square. When a equals to n, then you have 2n plus half square plus half square. I'll continue here. So what we have here, k is equals to 4n squared plus 2n plus 1 over 4 plus 1 over 4. And for this is 1 over 4 plus 1 over 4, that is 1 over 2. Okay, so this will be equals to 8n squared plus 4n plus 1. For this question, we are asked to write this k as a sum of square of two consecutive positive integers. So we can actually write as 2n squared plus 2n plus 1 squared. We check that when we expand this is 4n squared. This is 4n squared plus 4n plus 1. So the sum is equal to 8n squared plus 4n plus 1. That is correct. And we can do a simple check that when n equals 1, maybe I write here, do a little bit of checking. When n equals 1, k is actually equals to 16 plus 1 over 4 over 1 plus 1 over 4. 16 plus 1 over 4 over 1 plus 1 over 4. That will be 65 over 5. 65 over 5, that is equals to 13. And 13 can be written as 2 squared plus 3 squared. Okay, this is just to confirm that whatever we have here, that is correct, because when n equals 1, this is 2 squared plus 3 squared. We'll talk about the sum of square in tomorrow's discussion. That's all for today's lesson. I'll see you again. Bye-bye.